Hello, this is Professor Stephen Neshiba, and I'm here to help you out with getting started with Numpy in Canopy. I'll be working on a Mac, but on a PC there's a lot of overlap. I'll be talking about launching Canopy, how to create these things called scripts, assigning variables, and so forth. So let's just get right into this. If you've installed Canopy on a Mac, then it should be in your Applications folder, and there it is. Now I've already actually launched it, so I'll just pick it up right there. When you do launch Canopy, it will probably show up like this. I normally press this editor button, and then I'll get a screen that's going to show up what's called the editor window, which is this right here. Here's the file browser over here, and this is what we call the interpreter, or sometimes the command window. So what we'll do here is I want to create a new file, so that's what I'm going to do. Now, you're going to probably want to put all of your PChem-related scripts, which is what we're about to do, into a particular folder. So I'm just going to start off like this, but you can follow along, and I recommend that you do. The first command I'm going to put in here is a very simple one. It just says print hello. Okay, so that's very simple. The first time you create a script, what you need to do is save it, and that's what this icon is for. So I'm going to save it out to a place, and I've created a folder called pchem scripts, and so I'm just going to call this, if I can do it, hello.py in pchem scripts. And I misspelled it, so I'll fix that. Okay, and that looks pretty good. And now to run it, after you just press this green arrow button, and now we see the results echoing out here. This is just an echo of that run command, but here it printed out hello, and that's what I wanted. Now, if you want to change something on it, let's say I wanted to say hello pchem, and I run it again using the green arrow button. It notices that it changed, so I just have to say save, and hello pchem. That's good. Alright, so what are some of the other things that I kind of want to talk about here? We've talked about creating, saving, and executing scripts. How about assigning variables? Well, that's pretty straightforward. I'm just going to put some variables in here. Here's a variable A, which is going to be whatever, 3, and variable B, which will be equal to 4. What's going to happen is that Python is going to recognize that this is an integer, and that's a floating point or real number. Let's see, C will be equal to A times B plus 7. And I'm doing this just to show you that there's an order of operations rules that work in Canopy that is just like you're accustomed to on a calculator. So that's okay. It typed in hello pchem, and then, oh, it didn't print anything out. That's because I didn't ask it to print anything out. So I'm going to say print A, B, and C, and then you need a comma there. And so this is just a little prompt here, and then I'm going to say, have it print A, B, and C. Let's see if that does it. Okay. Oh, and there it did. It printed A, B, and C, their values right there. Okay, so there's that piece of it. Now, Numpy has a lot of Numpy is a set of mathematical packages that's built into Canopy, and to use them, they're very useful. What we need to do is import them. So that can actually be done anywhere here in this script, but it's kind of conventional to put them up at the top, so that's where I'll do it. And the syntax is import Numpy. Now we could do that and leave it just as this, but the convention is to make it a little bit shorter. So we'll say import Numpy as NP. And you'll see every time we try to use Numpy after this, I just need to say NP. Now, how are we going to use this? Well, there are a lot of functions in Numpy, but here's a couple: a square root and an exponent function. So if I want to say print, if I wanted to calculate, I don't know, D is equal to the exponent of C, I would say D is equal to np.exp of C. Okay, and if I wanted to say E is the square root of C, I would say np.sqrt of C. Okay, now there, if you wanted, I could print this out again. Print D and E, and let's see how that works. And it did. It looks like it printed out the exponent of C, and then it printed out the square root of C, so that looks all pretty good. And let's see if there's one more thing that lots of times what you really want to do is you want to create a whole bunch of numbers and create, let's say I would like to look at the square root of numbers from whatever, some 0 to 5. The way you do that then is I'll say x is equal to numpy dot linspace, in space, okay, a very handy command. And the syntax on it is, say, start with 0 and go up to something, I don't know, say 10. And what it's going to do is going to give us 50 numbers by default, 50 numbers between 0 and 10. And if I want to know what those look like, I'll just say print x. So let's see how that works. Oh, and there we are, from 0 to 10, 50 numbers, and so forth. Now, why is this, that's pretty handy there. Sometimes you might forget, or you might not actually know how many numbers it created. It just defaulted to 50 here. So that's what the shape command is handy for. So I'm going to say print np.shape of x, and run that again. And this hopefully will just tell us that that's what this second little bit is. It says that there were 50 elements in this list called x. And I'll do one more thing. Let's suppose I would like to know what the square root of x is over that whole range. I could say y, a new variable, is equal to np.sqrt of x. Okay, and maybe we want to. Maybe we don't care about what that looks like, but I'd at least like to know what the shape of it. What do you suppose the shape of it is? Print np.shape of y. Well, if you don't know, we'll just look at it. Okay, and so what did it do? Well, it created 50 numbers that would want to match each value in x, and hopefully it is the square root. And if I want to know what it was, I could say just print y, and then we see what those values look like. And there we go.